Moving on now to the results and analysis of experimentation, focusing on the important statistics that are used in psychology research. Statistics refer to the method of using mathematics to organize, summarize, and interpret numerical data, and can be split into two different types. First, descriptive statistics organize and summarize data in a useful way, gaining knowledge like averages, range, standard deviation, etc. And inferential statistics refer to interpreting data that can be used to draw conclusions and make predictions. We'll start first with descriptive data, looking at measures of central tendency, which answer the question, where is the center of the data? So this can be calculated in multiple ways, using the mode, which is the most frequent value, the median, the middle point of the data, gathered by looking at the total number of values and dividing that in half, and probably the most common, the mean, which is the average of the data or center of the data set, including any multiple values. Variability is another important quality to look at in your data, looking at how spread out the data is and just generally the overall shape of the data. Values corresponding to variability include the range of the data, calculated by subtracting the lowest value by the highest value, the standard deviation, which is how the data spreads around the mean, calculated by taking the square root of the variance, and the variance, which is the average of squared deviation scores. For example, taking a look at the graph, plotting IQ scores on the x-axis and the frequency of people who have each of these scores split up into groups of men and women. We can see that while the average IQ between men and women do not differ, men have more variation in their data than women, covering more of the lower and upper limits of the range. We can also look at skewness when plotting the data. A normal distribution occurs when the same amount of data is represented on either side of the mean, and the mean, median, and mode all line up at this center point. When we have a positively skewed or right skewed data set, the mode and median tend to be to the left of the mean, indicating more variance and potentially some outliers on the right side of the range. The opposite is true for negatively or left skewed data set, where the mode and median are to the right of the mean. In psychological research, having a normal distribution is important, as this allows for the most accurate statistical analyses possible. Because the normal distribution is so predictable, we can reliably estimate probabilities at any point under our normally distributed curve. As we go farther away from the mean, less and less of the population are likely to achieve that score. As an estimation, around 1.6 standard deviations away from the mean represents the most extreme 5% on one side of our histogram. If we were to randomly select an individual from a population, there would only be a 5% chance of selecting an individual whose score deviates that far below the mean. So if the probability of an event is less than 5%, we can call that a rare event. And we use this number often to decide whether or not our findings are strong enough to either accept or reject our hypotheses. Remembering back on to earlier in the lecture, descriptive research focuses on correlations, or the investigation into the associations between two or more measured variables. The relationships between these variables can tell researchers a lot about their questions of interest, making this important information to gain. But it is also important to remember that correlation does not equal causation. That's where our experimentation comes into play. Correlations focus on how two variables are related and provide information on both the direction and the strength of the relationship between two variables. Take, for example, the graph on the left. As studying increases on the x-axis, the grade performance also increases, making this a positive relationship. However, in the middle graph, as the number of absences increases on the x-axis, the grade percentage gets lower, making this a negative relationship. The third graph represents the same information as the first, as studying increases, performance increases, but this graph shows a difference in strength. The data points are much more varied and distributed around the correlation line, meaning that this relationship is weaker compared to the strong relationships shown in those first two graphs, where the data points are very, very close to those center lines. Correlations are represented using the correlation coefficient, or the lowercase r, and describes the nature of the relationship between two variables. R ranges from -1 to +1, with the sign indicating the direction of the relationship, either positive or negative, and the absolute values indicating the strength of the relationship, or how closely those data points line up to that midline. A positive correlation occurs when an increase in one variable relates to an increase in the other, and is represented anywhere from 0 to 1, depending on the strength of that relationship. A negative correlation occurs when an increase in one variable relates to a decrease in the other, and is represented anywhere from -1 to 0. A correlation of 0 indicates that there is no relationship, that the two variables are not correlated with one another at all. Scatter plots are a useful tool to visualize the correlations between variables. We can see clear differences in the distributions of data points corresponding to each of the different types of correlations. With the positive correlation on the left, showing an upwards trend from low to high on both the x and y axes. A 0 correlation does not show a trend in the data points at all and would result in a straight line across as the midpoint of the data. And the negative correlation on the right, showing a downwards trend of the variable on the y-axis as the variable on the x-axis increases. There are many advantages to using correlational research. It shows the strength of relationships between variables of interest. It can be used to make predictions about variables, as we can extrapolate into the future and the past based on the relationship we know. And it also identifies real-world associations, specifically about the relations between two variables or concepts of interest. Some disadvantages to correlational research include the fact that we can't assume cause-effect relationships exist between these variables. As we've heard before, correlation does not equal causation. So we don't know whether the change in one variable is due to a change in the other or vice versa. Additionally, we may have the case where the relationship we found may actually be due to a third unmeasured variable that has an influence on both variables in the relationship. Due to these, it can be helpful to think of correlations as showing an association between two variables rather than thinking of either variable as a cause of the other. For example, there's a known negative correlation between birth order and intelligence. It obviously can't be that higher birth order causes lower intelligence, so what else could be going on? This is a topic that researchers have studied for a while now, and it seems that social rank might be the sneaky third variable behind this association. So for firstborn children, parents can dedicate all their time, energy, and resources into important developmental maturity, both cognitively and linguistically. And as the second or third or fourth and so on children are born, they're sharing less and less of their parents' resources. Additionally, older children often have the added benefit of being teachers to their younger siblings, which also has an important cognitive effect. And this is all really just to show that simple correlations often have much more complex stories behind them, and that associations may not be causative at all. Similarly, if we look at the relationship between social relationships and happiness, it would be tempting to conclude that having better social relationships leads to increased happiness. However, personality style is known to influence both of these variables. So it could actually be the fact that these two variables are not related to one another at all, but are actually mediated by a third variable altogether. There are, of course, some other things to watch out for when evaluating research. First off, sampling bias. So when a sample is not representative of the population, for example, if a poll only asks men, the outcome may be different than if the population is both male and female or gender neutral. Furthermore, the acronym WEIRD stands for Western, Educated, Industrialized, Rich, and Democratic. And this represents a criticism of science's heavy reliance on a particular type of human participant. This likely affects many research outcomes and truly highlights the importance of cross-cultural research. Moving on to placebo effects, when a participant's expectations lead them to experience some change, even though they receive empty, fake, or ineffectual treatment. So for example, when subjects are cured by a sugar pill. Additionally, it's common to find distortions in self-report data through social desirability bias, or a tendency to give socially approved answers to questions about oneself. For example, did you vote? Effect of response set, or a tendency to respond to questions in a particular way. So sometimes simply by agreeing with everything. And also the halo effect, or the tendency to let initial performance or liking affect future judgments of performance. Lastly, experimenter bias. So when a researcher's expectations or preferences about the outcome of a study influence the results obtained. Researchers can sometimes simply see what they want to see, and these errors are usually in favor of their hypothesis. Similarly, researchers may unintentionally influence the behaviors of their subjects, possibly through things like body language or smiles and other things. So to control for this problem, a double-blind procedure in which neither the subjects nor the experimenters know which subjects are in the experimental and which are in the control groups that are being used. In this case, a non-directly involved researcher keeps track of everything so it can be sorted out at the end. Ethics are a critically important part of the psychological research and refer to a set of general principles of how people should be educated, treated, and respected when participating in any study. Internal review boards, or IRBs, review and assess if a research project will be carried out in a way that is consistent with the general ethical principles. And these include whether the study uses a sound research design, that the risks associated with participation in the study are minimized and reasonable, that the benefits of the research outweigh any potential risks, that all participants can make an informed decision to participate in the study, and that their decision may be withdrawn at any time without consequences to the participant. Also, that safeguards are in place to protect the well-being of the participants, and lastly, that all data collected will be kept private and confidential. Some populations of interest require additional considerations. Potential participants that are not able to legally give informed consent, such as children or other individuals from special populations, they require 2 additional criteria for participation. The first is informed consent from the parent or guardian, and assent from the potential participant. Sometimes informed consent may affect participants' natural behaviors and reactions that the experimenter is interested in. Some studies might not reveal the true nature of the study until after participation is complete. This is known as dissection, and also goes through a review process to ensure it does not adversely impact the participants involved.